Good afternoon. So, in last discussion, I give you the material about the second order ODE, but this is the homogeneous. So, in this video, I will show you um, how to get the general solution of non-homogeneous of ODE. So, this is the general form. So this is the title is similar, the second order ODE, but this is the non-homogeneous. Okay, so this is the general form of non-homogeneous ODE. That is A d quadrat y per dx quadrat plus b dy per dx plus cy. So this is equal to fx. So this is the general form. If we have so the title is the second order ODE. Okay, the title is similar, but this is the non-homogeneous ODE. So the differences on this, the difference between the homogeneous ODE is the right side. If the non-homogeneous, the right side is equal to 0, here is equal to 0, but for non-homogeneous, the right side is not known as 0. So how to find the general solution of the second order ODE, non-homogeneous? The first one, we have to find the general solution of homogeneous equations. So it means that in the first one, we have to assume that the fx here, the fx here is equal to 0. So if we assume that the fx equal to 0 is this is the homogeneous equation. So we can find that we'll get the complementary function. So we can get complementary function of ycf like this one. And then the second step is find the particular solution, or EPS. This is the particular solution, and the CF is complementary function of the full equation. Okay, so for the summary, the first one, we have to find the YCF from the homogeneous function in the second order ODE, and then after we find the YCF, we have to find the YPS by using the general form of Fx. Fx is the right side of the second order. Yeah, you have to remember that the general form of second order is like this one: Y double accent plus Y accent, like plus or maybe like this one: A d quadrat y per dx quadrat plus b dy per dx plus cy is equal to fx. So this is the general form. This is the general form of the second order non-homogeneous ODE. Okay, so the fx here is right side. So we have to find a YPS. So how to find the YPS? So this is the summary. If fx is constant, so the YPS is C. It's constant. It's linear. X is like AX or AX, BX, something else, a constant. So the form of YPS is CX plus D. And quadratic in X, so the form of YPS is CX quadrat plus DX plus E. if the fx is k sin px or k cos px, so the form of yps is c cos px plus d sin px. If the fx is k e power of px, so the yps is c e power of px. If the product of above, like this one, linear plus quadratic, so the form also the product of the above. Sum of the above, also the sum of the above. So, so this is how to find a solution or general solution of the non-homogeneous ODE. I will give you a brief example. It's like number 1. If we have y double accent minus 2y accent minus 2y is equal to 6. So the first one, we have to find the YPS, a YCF from complementary function. The first one we have to find the complementary function of these equations. So we assume that the second order equations from the problem is equal to 0. So it's equal to 0. So we'll find that this is m quadrat minus 2m minus 3 is equal to 0. So m minus 3, m plus 1 is equal to 0. So we get that m1 is equal to 3 and m2 is equal to minus 1. Okay, so we have a different rows here, m1 and m2. So the general solution of ACF is equal to a e m1x plus b e m2x, like I explained before. So we can that the complementary function is a e m1 is 3x plus b e minus x. Okay, this is the first one, complementary function of this equation. And then we have to find the number 2 is YPS. The YPS is depend on the fx. Okay, so the fx is 6 here, so YPS is constant. Okay, so like this one, if you remember, this is the constant, so we use the first one, constant. So the form of YPS is C, or constant. So because of the fx is equal to 6, so YPS is constant. Then this is the constant. So if we make a differential of the constant is equal to 0, and also double accent of the is also a 0 because of the constant. If we make differential of the constant, is must be 0. So if we substitute to the equations, the equation is y double accent minus 2y accent minus 3y is equal to 6, right? So we make substitute with using this this solution. So we can get that y double accent is 0 minus 2 y accent is also 0 minus 3 y ps is c. Okay, so this is equal to 6. So c is minus 2. So we get from 2 of this one, this is the first one, the complementary function, and this is the YPS. So the general solution is y is YCF plus YPS. So we get that a e 3x plus b e power of minus x minus 2 here. 2 is from the particular solutions. Okay, so this is the general solution. The first one here is coming from the complementary function, and this is from the particular solution. So this is how to solve the second order ODE if non-homogeneous. So I will give you another example. Number 2 is y double accents plus 5y accents plus 6y is equal to 2x. Okay, so this is the linear function 2x. So we have that from here. We can find that the first one we have to find the complementary function. So m quadrat plus 5m plus 6 is equal to 0. So we have the m plus 2 and m plus 3 is equal to 0. So we have that m1 is minus 2 and m2 is minus 3. Okay, so this is the difference also. So we have that the complementary function is a e m1x power of m1x plus b e power of m2x. So we get that a e minus 2x plus b e minus 3x. Okay, so we find this is the first one. We have the complementary function. And then the second, we have to find the particular solutions. So the fx is equal to 2x. So the general form of yps, if the right side is linear of x, so this is must be cx plus d you can find here. Yeah, if this is a linear function here, the red line, so the solution is cx plus d. Okay, and then we use like this one, y accent ps is c. Okay, the differential of this equation is c, and y double accent ps is 0. So we make a substitutions to the equation. So we find that the equation is y double accent plus y 5y accent plus 6y is equal to 2x. So the y double accent is 0. 0 plus this one 5y accent. So y accent is c plus 5c plus 6, and then 6y, so, and y is cx plus d, so we have like this one, d is equal to 2x, okay, because the fx is 2x. So we find that 5c plus 6d plus 6cx is equal to 2x. And then so we make a similarity between the left side and the right side, and we have the constant term. Constant term is this one, so 5c plus 6d equal to 0. And then another is coefficient of x, 6c is equal to 2 in this here, because the coefficient of x, so 6c is equal to 2. So from 2 of this equation, we find that the c is equal to 1 per 3. So we have the d is equal to minus 5c per 6, so equal to minus 5 per 18. Okay, so the general solution is must be y equal to yps plus ycf. Okay, ycf is this one. So we write a e power of minus 2x plus b e power of minus 3x plus the solution of this one, the particular solutions. Yes, the particular solution yps is cx plus d. So c is 1 per 3, so 1 per 3x minus 5 per 18. So this is the yps. So the solution we have to add with the particular solution or complementary solution. 1 per 3x minus 5 per 18. So this is the solution of number 2. Okay, I think this is enough for my explanation. Thank you very much for your attention. Bye bye. Good afternoon.